Today I'm going to talk to you about my research at the university here in the Department of Astronautical Engineering. I'm fortunate today to have two students with me, Nazareth Ashkarian and Marcel LaRiviere, to talk about how we in the department are promoting commercial spaceflight through protecting the participant. What is really unusual is that although we are beginning a new era in human space exploration, we are starting in a field with no governmental regulation. Unlike the evolution of the aviation industry, we have the opportunity to start and build on 50 years of human spaceflight experience. In the old days with airplanes, it was fly, fix, fly. And during that time, we lost many lives that led to innovation in aviation. Today, we have the opportunity to design and certify and protect the occupancies without ever actually flying and risking human lives. We've lost some lives in our quest for space. However, we have been able to learn and improve on those lessons and do it so new vehicles can launch safely and provide mission assurance to the participants. This at USC is what we are trying to promote. We look to other industries like the Formula One industry for Formula One auto racing, for offshore safety in deep sea drilling, and for nuclear power to look how the key to this is allowing these industries to provide their expertise to self-regulate. 50 years of human spaceflight. This is a complicated slide, but what we have done is we have learned to establish standards, establish fault tolerance, how to avoid failures altogether, how we can identify risks, quantify the risk to the participants, establish controls to mitigate those risks, and make it safer for all those involved, from ground operations to those who are flying, to the general public who may be affected as we enter airspace and the such. NASA has learned how to do this. They have established a process for safety, and we want to take that process and apply it to the commercial space industry and learn from this 50 years of experience. The Department of Astronautical Engineering was established in 2004. We've set up bachelor's degrees, master's degrees, and doctoral degrees in this field, and it's among the largest programs in space engineering, and we want to be at the forefront in research and education. We have an active student body doing things from designing their own rockets and competing in the new university space race to be the first student group on a student-run project to advance to the von Karman line and to reach outer space. And they've been incredibly successful, and we hope to meet that goal. My individual research has been also focusing on commercial space, looking at writing and leading the development of international standards to apply the consensus standards from industry and existing expertise. We are also understanding how to do risk assessment of complex programs and have been looking post-flight on the Red Bull Stratus with Felix Baumgartner and the Paragon Strat-X with Alan Eustace. And we are doing our own balloon flights, both looking at helium high-altitude balloon flights and using a sustainable method through the Aeroscene solar air balloon projects. The solar eclipse was on October 19th, 21st, and provided an opportunity for us to test out these hardware and processes. And I'm going to introduce one of my students, Nazareth Ashkarian, who recently received his graduate degree from USC in the Astronautical Engineering program and is now working at the NASA Jet Propulsion Laboratory. So come on up, Naz.
Thank you, Michael. And so for the solar eclipse on August 21st, we had two balloons that we flew. Like Michael was saying, there was a helium balloon and also a solar balloon that's actually parked right out here of our tent that you might have noticed. It's quite big. And so the helium balloon, like Michael was saying, standardizing commercial space flight and safety, we want to take this opportunity to incorporate some of those practices of risk analysis and hazard analysis and put those into the project, and it just so happened to be a helium balloon. And in this image, there is the launch for the solar eclipse. And so with those practices in mind, for instance, contacting the FAA for clearance, or assessing some of the designs so that everyone who is part of the project on the ground and also in flight and when the balloon lands, that everyone maintains safe and follows those standards from commercial spaceflight. And it was also a really neat opportunity to put on some science experiments to see how the atmosphere is going to change during that solar eclipse. So we put in things like ozone sensors and methane and carbon dioxide, and we got to see, when you turn that big light off in the sun, what actually happens to that atmosphere. And so this is just a quick image of us letting the balloon go. And conversely, the solar balloon project, unlike the helium, it only uses regular air. And so instead of using or manipulating the low density of helium to lift the balloon, it just uses solar heated air to pressurize and lift the balloon up into the atmosphere. And this is a different type of safety problem with a different, what we call a flight envelope, that it will go at a different altitude and it will have a different flight path. And so with these practices that we learn, we try to build predictability and try to figure out what the balloon is doing with the physics and documentation and science experiments that we conduct on those balloons to reduce the risk and predictability of the future flights for this balloon and other commercial space flight conversely. And this is a cool little video of that solar balloon launching at Craters of the Moon National Park in Idaho Falls during that solar eclipse. And so we got to get some cool data and some cool videos, and again, it only to advance that commercial spaceflight aspect through safety and mission assurance. Thank you.
What did it fly for?
The altitude of the solar balloon reaches about 50,000 feet, so a little past commercial jetliners, and the helium balloon actually bursts at 100,000 feet. And so that is a more direct flight, and then this kind of coasts.
Did you find changes in what you were looking for? Also,
Yeah, the question is, were there any changes? And yeah, we did see some changes. We actually had 2 flights, one on the weekend before and one during the eclipse, to kind of get a baseline. And so we, with science, you wanted to try to compare with past measurements and see what we call deltas, just the changes that we kind of witnessed with different factors.
did they compare it with day and night changes?
Yes, question compare with day and night. When it was kind of really interesting because when the solar eclipse
because you
happened,
switch the sun in the night.
yes, it was absolutely almost like night when the sun was 100% covered. And so we did see those types of phenomenon as if we were flying at night for those couple of minutes.
Well, thank you.
Thank you. Oh, sure. If there is a little bit more time, in regards to those baseline measurements, there was also another experiment that we flew from Cornell for what we call extremophiles, these bacteria that are very hardy in space. And so we wanted to see how they would survive in a low radiation, low atmospheric environment. NASA thought, oh, well, that's kind of like Mars. So if they turn off the sun for a little bit, maybe we'll know for a couple minutes what it would be like Mars. And so we had the same bacteria on the ground and then put the same bacteria up on the balloon and saw what the difference was during the eclipse and then the baseline measurement, and see, is it possible for, in these kinds of conditions, for life to exist, and maybe collect some data and some papers for other scientists to use and further their research and make new scientific experiments for the big questions like, is there life on Mars?
But the radiation is delayed by 8 minutes.
Yes, so if the solar eclipse happened, maybe that delay in radiation, even though we see the light, it's 8 minutes of when it actually happened. But to us, it's almost like if I was on the sun, it would have been at 12 o'clock, but on Earth, it would have been 12:08. You're absolutely right.
Great. Thank you.
Thank you very much, everybody.
Next talk in a half hour.
If you can find out more on goastro.space. Thank you.